Okay, so let's start. Okay, welcome everybody. Today we'll give you a presentation about Git, a brief introductory course, let's say, about Git. I will start with a brief presentation of slightly 50 minutes of slides, and then I will go with a live exercise that I will, let's say, do in live to show you some examples, let's say, of how to use Git. You will find everything on the repository that I've linked, that I put the link in the mail in which I, let's say, also send you the link of Zoom. Both the slides and also the markdown file with the exercise that I will go through later. So let's start. Git is a distributed version control system created by Linus Torvalds, that is also the same creator of Linux. You can find again the slides of this brief course at the following link. So let's start seeing the difference between Git versus GitHub or GitLab that sometimes get confused, let's say. Git is a version control. It's a system that records change to a file or set of files over time so that you can record specific versions later. And therefore, you can also use it completely locally on your machine to just track down the version of your code. While GitHub and GitLab or other services of this kind are developer platform that allows developers to create, store, manage, or share their code through Git software. Therefore, clearly, the two of them are deeply bound, but they're not the same thing. This is important to, let's say, keep in mind. Okay, so let's start from the most basic Git, let's say, function, Git clone. If you want to copy an existing remote repository on your local machine, you will use Git clone with the remote URL. This creates a directory named local directory, or the standard name of that that was chosen for that specific remote repository on your local machine, initializing it within itself a .git directory. Remember to do not touch this directory since it contains all the files necessary to Git to work properly. Therefore, do not touch it unless you want to delete your local repository. In that case, you can just delete it, of course. Git clone also puts down, therefore download, all the data from that remote repository, and therefore it creates a copy of that repository on your local machine. Regarding the remote URL, you can always choose to use the HTTP protocol or the SSH protocol. The HTTP protocol will be used, for example, if you want to load the slides for this course, because the repository with the slide of this course. Since you don't have the access, they have the right access on that repository, since it's just mine, you will just want to download what is inside. If instead you want to work on a repository, because it's a repository of your colleague, or it's your own repository, you will like to use the SSH protocol in order to, let's say, work more efficiently without always to put passwords to do operations with the remote repositories. So let's see in which states Git files can be. Let's remember that you have your working directory. In your working directory, you have your staging area that we understand what it is right now. And then you have your Git repo directory that contain the local repositories files. Your file, the one that is already inside your repository, can be modified. This means just that Git feels that the file is changed with respect to the last commit that you have done, the last snapshot of your code. Once the file is modified, you can, let's say, stage this file. That means mark this file as modified with respect to the last snapshot, and mark as in the meaning that you want this new modification of the file to be in the next snapshots, okay? After the staging phase, you will commit your file to completely save your work and store your, let's say, changing to your next commit or snapshot. Remember that Git thinks about its data like a stream of snapshots. save always a snapshot of your code, while the commits are sort of like pointers to these snapshots, okay? Let's see more details, a file's life cycle. The files in your Git repository, locally, of course, can be unmodified or untracked. Unmodified files are just files that were already added to your repository and are just saved in the last snapshot. Untracked files are new files. You can also have modified files, as we already seen. To add untracked or modified file, we'll just use git add those files, or -a if you want to add all the files necessary, all the files that you can add, let's say, in that repository, to stage that files. Another way to stage files is in the case you want to remove those files or move. By move, I mean you want to move the position or change the names with these two commands, git remove and git move. Remember to always use git remove and git move and not to use the normal remove or move, since git remove and git move, let's say, makes your life easier with respect to the managing your repository. In particular, if you want to remove a file both from the repository and your computer, you want to use just git remove. If you just want to untrack that file, therefore remove it from your version control system, from your, let's say, repository, but not from your computer, you will need to use the cached option. Using this command to your files will make these files staged. Therefore, they will also be in this, let's say, stage. Once you have your files staged because they were added, removed, moved, you can commit your changing to create a new snapshot of your code. The added file or modified file will be again unmodified. The files that you have removed will be untracked or just went lost if you just use git remove. If you do not use git remove or git move, but just remove and move, of course, you will be able also to add and remove files properly. But let's say it's less convenient since it's more convoluted. Since, for example, if you move a file with a normal move command, Git will feel like you have created a new file and removed an old file. And so you will need to work a little bit more to fix this. Moreover, if you use this command, the history of that file will be easily retrieved in the history of your commits, while in the other sense, in your history, those files will come up from nothing, while the old file will be disappeared. Okay. Other very important commands of Git to understand in which status your, let's say, repository, your local repository is Git status. You will use this file, this function continuously to understand which files are staged, which are unstaged, with the modification you have, if you have untracked file, everything. Git diff instead will show you the difference between your changing, your, let's say, modified files with respect to the last commits. It's very useful to understand what you have done with respect to the last snapshot that you had. You can use it on a single file or without anything to just see all the difference with respect to the last snapshot. Another very, very important command is git log to see the history of your commits. These other options that I add here are very useful for visualization in the terminal to just see a more compact history of your commits in, I'd say, more in a more nice way, because git log alone can be quite confusing sometimes. Another very important feature of Git is that, of course, if you need it, you can ignore files in putting some a sort of a file listing patterns in a file called .gitignore. This is an example of a .gitignore of stuff that you maybe would like to put inside of it. You, of course, would like to avoid pushing in your repository object files and, of course, also .x files that are the executables. Maybe if your code outputs are, for example, .dat file, you would also like to avoid pushing those files in the repository with this string. But maybe your code uses init files that end in this way. using the exclamation mark, you avoid ignoring files that end up in this way. You can also ignore entire folders like build, for example, where people usually compile the code, or folder like .vs Code if you use an editor that create a folder inside your repository, like VS Code does. An important feature of Git is that you can undo stuff. Of course, you can always retrieve old version of your code, and this is quite nice. You can improve your previous commit by git commit amend, unstage or unmodify a file using the git restore command with the staged option to unstage a staged file, or alone if you want to unmodified a file. In the live exercise later, we'll see application of this kind of stuff. You can also undo commits, entire commits. This we are still speaking of local changing. It's important to remember. Using git reset. Git reset is more dangerous. We'll see some details later, also talking about remote repositories. Let's talk of one of the most important feature of Git branches. The possibility in Git to have multiple, let's say, pointers to different history of your codes, to have, let's say, possibility of having your code in different states at the same time, okay? You can create new branches by using Git branch and switch to existing branching using Git checkout. Remember also the existence of the pointer head, which is a particular pointer that always points to the local branch you are currently on. This is just a cartoon of an example of a, let's say, a tree structure history of a Git repository. Remember that the master or main branch is always considered the most, let's say, important. It's called master for GitHub on the default and main on GitHub, on GitLab for default. And then you can have your branches wherever you want. Here, if somebody is working here, the last commit was made in the branch 1.2 here, of course. Once you have a history of your code like this, how do you manage to merge this branch in your master branch in order to, let's say, control all this feature and to let's say put them inside the main version of your code, let's say the branch that contain the stable version of your code using merges, in particular the git merge command. Remember that git merge is used in this fashion and will merge the branch you choose onto the current branch you currently are. Let's say there's there's a lot of type of merges. Let's see the two most important, starting from the merge commit, that will create a new commit snapshot that results from this three-way merge. Let's understand this, let's say, sentence. Let's start from this cartoon. You have your master and a red branch, the B1 branch. Their history is diverging. This means that the master is going, growing up with respect to the commit from where the red branch started. If you merge in this moment, a new commits will be created, a new snapshot, C4 for the master, since you are merging, of course, you're merging B1 onto the master. B1 will remain at the C2 commits, while the master will keep going with these new, let's say, commits. C4 is just a merge commit. And in this way, we'll create a sort of divergent history. This sort of extra branches in your commits history, okay? Another very nice way of merging branches is using the fast forward merge. It's a special case of merge that happens if there is not a divergent history. If your branches are in this kind of configuration, there's no, of course, the history of the green branch coincide with the history of the main branch. If you merge, the pointer of the master branch will just be moved forward to the end of B2 branch. Therefore, the C1, C2, and C3 commits will just belong to the master right now in this fashion. B2 will remain in this commit, and the master will keep going, of course. This is very nice, since when you look back at the history of your code, at let's say the old stable version, you like to see a linear history, since it's more easy to understand how the code have evolved. If you imagine that a huge code has tens of branches and all of them will merge in a merge commit fashion, you will have this convoluted tree-like history with a lot of diverging branch that will be a mess to navigate inside it. While in this way, you will have a linear history. And this is the reason why Git rebase exists. This command, what it does is take all the changes committed in the current branch and reapply them on top of the new branch you want. So in this case, you will be, for example, in the red branch, and you will rebase onto the master. In this way, all the commits of B1 will be applied to the last commit of the master branch, C3. You will end up in this situation. Why this is nice? Because if you merge in the first case, you will have a merge commit, therefore a divergent history, more hard to read, that makes more hard to read, let's say, the path of your code. If you merge in this fashion, instead, you will have a fast-forward merge that will make your history linear, more easy to be read, of course. So until now, we've talked just about your local repository. You can just use all this stuff on your computer and be happy with it if you just want to version control your own code or your own computer. Of course, one good feature of Git is that you can collaborate with others. Remote repositories are versions of your project that are hosted on the internet or networks, GitHub, GitLab, or whatever service you want to use. And they are very useful to collaborate with others, share your work, or just even for having a backup of your code and your, let's say, version control history. If you already clone the remote repository, as we already see Git clone in the first slide, you can just use git remote command to check, let's say, the remote status. In particular, git remote -v will show you the URL that you have used, and therefore you can retrieve the remote repositories. Otherwise, you can, of course, initialize a new local repository from scratch, create a new repository also on your favorite service. For example, I always use GitHub, and connect the two of them using git init to initialize the local repository, and then git remote add to connect your local repository and your remote repository. Some other useful information about managing remote repository is the command git config. Git config allows you to set some Git variables. For example, if you use SSH key protocol, that is very useful, you will like to use this command, git config global user email and username, in order to set your mail and name in order to easily have access to your own repositories or a repository in which you have write access. If you have multiple if you have multiple accounts, you can always use the local option in a Git repository in order to set a specific mail and name for that repository. If you have multiple accounts, of course, you can check your configuration using the list. Another very useful option that I always use is the git config global core editor in order to change the core editor or Vim, the editor that you will use for commits, for managing merging, conflicts, stuff like that. It is useful because the default editor is Nano. I don't know for you. For me, I don't use Nano. Therefore, every time I always change it to Vim. Of course, you can change it to whatever editor you prefer. So let's come back and see again how to undo things in Git, but this time also speaking about the remote repository. We already see git reset that is used in this fashion for example, to reset the last commits or the last 3 commits, for example. This is a short cartoon to understand this example. This was the state of your repository at the start. After resetting the last commit, your head will come back. You will completely delete the C4 commits locally, but remotely, if you already push that commits on the remote repository, will still exist. Therefore, if you're just working alone locally, is doable, even if it is quite dangerous, is not, let's say, the best practice if you work also remotely. And in particular, what is you are doing here is really deleting snapshots, so can be dangerous, as you can understand. The command revert instead is much more safer. What it does is that, again, you can revert the last commits or the last three. Remember here to notice here that revert doesn't take just a commit, it takes a range of commits. If here you just put head -3, or where the minus is a tilde, you would just revert the changes of 3 commits ago, not the changes of 2 commits ago, for example. With this range, we will revert all the changes from 3 commits ago to the last commits. I hope that this is clear. In this example here, an example where I revert just the last commits, I show you what revert does. If you're in this situation and you revert the C4 commits, a new commit is done, C5, that made changes, that let's say revert the changes of C4, and therefore C5 will be the same exact state as C3, but as a new commit. In this way, you do not lose the history of your commits. You do not lose your snapshots of C4, as instead you lose it in this fashion. Of course, if you have pushed it, you have still it online on the remote repository, but still revert is more safe, of course. Now, let's see how to, let's say, grab stuff from the remote repository in your local repository using git fetch and git pull. Git fetch pulls down all the data from the remote project, and we'll have, at this point, you will have references to all the remote branches, and you will be able to merge with local branches if you need, or just inspect at any time those new features that were just remotely. Therefore, since git fetch and git merge are tightly bound, since sometimes if you want to pull down stuff from the remote repository, you want to update your branches, a new, let's say, command has been created that is git pull that automatically fetch and then merge from the remote repository in your current local branch. Git pull has some cool, let's say, options. All the git commands have a lot of options, of course. In particular, these options are here because git pull inside of it is doing a merge, and therefore you can specify which kind of merge you want to perform. A rebase maybe, a fast forward. You want git pull to just use fast forward, and if not gives an error, you can use fast forward only options. There's an infinite amount of options for Git, and therefore you will find yourself looking at the documentation if you will keep going using it, of course. Instead, how to update what's on the remote repository from your local repository using git push, of course, that will send the missing object. It seems that I will have a problem with Zoom. I will just restart the Zoom meeting if the Zoom call will fail. I was saying, using git push will send missing object to the remote repository and updates the remote branch, of course. The command will work only if you clone from a server to which you have write access, of course, and if nobody has pushed in the meantime. The second condition it will be explained here in this, let's say, small cartoon. If a collaborator of yours push at a certain time, T0, you won't be able to push after its push. This command from your site will be rejected. Before pushing, you will have to fetch or pull their work in order to incorporate their work with yours, in order to, let's say, merge locally on your repository, resolving conflicts and stuff like that, and then push again on the remote repository. This will be accepted. This is very important to avoiding having, let's say, non-linear history of single branch on the remote repository. Of course, this applies only if both of you are using the same branch. If you're using a branch and your collaborator is using another branch, you won't have any problem. And this is the rigor powers of branch, of course. A particular type of A particular type of push is the push after a rebase. Let's say you have rebased the branch B1 onto the master. Therefore, you are in this situation, as we saw already before. The red branch is in this configuration, rebased on the C3 commit of the master. The remote branch of the red branch, the B1, is still based on the C2 commits of the master. And therefore, you have created a divergent history on the branch itself. B1 local is divergent with respect to B1 remote. Git push in this particular case will be rejected from GitHub, GitLab, or whatever service you use, unless the service you are using doesn't have any safe control, let's say. You will need a git push, or I will suggest you to use git push. You will need a git push force, of course. Or to be more safe, a git push force with Liz, this green option. Since git push force can delete stuff and make a mess on the remote repository, is not very, let's say, recommendable. Git push force with Liz instead is a more safe option that won't do any harm, let's say. Let's just say like this. The reason why it's so hard, let's say, to do a push after a rebase is because the rebase should be used in another fashion. Once you have rebased your branches in this way, you will like to merge this local branch onto the master, avoiding a divergent history and creating a sort of linear history for the master branch. After this operation, you could just delete your B1 branch, both from local and remote repositories, since all the commits of that branch are already incorporated linearly in the master branch. However, sometimes somebody wants to just rebase its own branch, but still keep working on it. In that case, you will need a push force. So finally, also ironically, I would say, we'll see more details git init command. As we already know, git init will create a local repository, will initialize a .git folder. Remember to do not touch the .git folder. You will need to add the files that you have in your folder and commit your first commit in order to, let's say, create the first snapshot of your code. At this point, you want to connect your local repository to the remote ones using git remote add origin, where origin is the name of your remote branches. You can also change it to be remote or Mario if you like it, but let's say the default name that you will find everywhere online is origin, so I recommend to just stick with it. And then, of course, the URL. What origin does is that if you have, for example, local branches that are called master and HPC, for example, the remote ones' names will be origin/master and origin/HPC, okay? After the connection between the local repository and the remote repository, you will need to push. You cannot do a normal push since on the remote repository, those branches doesn't really exist. You have the name origin, but master and HPC doesn't exist. Therefore, you have to push an upstream version of these branches. And the -u is exactly what it's doing. This -u stays for upstream and will create the origin master branch if you use it as origin master, or if you use it as origin --all, it will just create all the local branch on the remote repository. Therefore, it will create, for example, in this simple case, origin master and origin HPC. As a reference, I leave you, of course, again, the link to my Git introduction repository. A Git book, the link is here. Very useful, is free to be downloaded. So I suggest you to use it if you are going to use a lot of Git. And also the documentation of GitHub and GitLab are, of course, very, very useful. This is the end of the presentation. Now I'm going to start the live session. It seems I'm gonna have a problem with the Zoom call. Therefore, I will just close the call and reopen it. And we'll start in a minute. So see you here in a minute with the live session.